I said, just to avoid the intersections and cul-de-sacs. And we're gonna start our intersection and cul-de-sac design with polylines. But what I'm gonna tell you to do is to, right now, where do you have your buildings and driveways? In with your properties? All right. I want you to take those buildings and driveways, copy them to the clipboard with a base point of 0, 0, and paste them into a new file with that same base point of 0, 0, and save it as, you know, design, call it, or layout, site layout or site design, something like that. Let me see. Hooray. Okay. So give us a minute to warm up.
Professor?
Yes.
What were the returns on the driveways?
Don't put curb returns on the driveways,
Oh,
just
not the actual, like.
the dimensions that we had, okay. Ah, not good. But you're still logged into the wrong one. So let's try it again, log in. Dun, dun, dun. Okay, so our driveway dimensions. We had our home. And I told you, and this of course is a break line, this can continue down. Did I give you guys 32? Or 30? 30?
Yeah.
And we did, actually, this doesn't have to go all the way to the end. Hang on a second here, let's shift that up. This over here could have been 30. And this was R equals 5 feet. Okay. And remember, our driveways extend to the curb line, not to the right-of-way. So I told you guys to take your buildings, paste them into a new drawing. And in that drawing, keep nothing but your buildings, driveways, and your proposed curb. 2D polylines. The proposed curve you can generate by offsetting your alignments or copying them from one drawing. Keep them as a 2D base map, and this is going to help you with your printing, because you're not going to be printing your corridors unless we want to go through a week of code set styles and stuff. And a file like this could be used for a lot of reasons. Also, help you with your zoning. You can put your zoning table in there and compute your lot covers on there if you just bring in your XREF in your subdivision, and you can move it back and forth. But you can take this file and bring it into your sheets when you're ready to print. You can bring it into your SCD sheet, your proposed sheets, your residential grading sheets. And please stay alive, don't die on me. Other than that, let's see. All right, let's give it a shot and see if we get hooked up. All right, here are the base maps for the projects. And in the engineering, I have my subdivision 2. I don't even have that. I have my roadway grading. And this is where I want us to start off. Okay, so this is where I left off last week with you guys. I basically did some very rough road grading. I generated my alignment, my existing ground profiles and proposed ground profiles. Go away. Let's see if we can go for a little bit. Huh? And I told you guys to make one corridor for each section of roadway that doesn't have a cul-de-sac or an intersection. And let's look at this and see if I can get away with something that's not going to be right. So, what do I have here that a lot of you guys are missing? The return on the property, all right? That return, or the one that is farther inside your property, is where the corridor stops. All right, same thing over here. I've got these 2 returns. They are symmetrical with the 90-degree angle, but if they were offset, I would again, my corridor would end right on that curve return. This one would end right on that curve return. Same thing with all of them. And down here, what am I missing? I drew this on a lot of yours. These also get returns. The radius is the same radius here. Okay. All right, so I am going to do my best without the software to teach you how to grade an intersection with some stick figure diagrams and hopefully good descriptions, all right? But the first thing we need to do is realize that there's a curb out here, isn't there? Right? There's an existing curb. And I told you guys that in an ideal world, when I really build this new road, I don't want to disturb all the pavement out here. I'd really like to just cut that curb right at that gutter's edge and tie my new work into it, and that's it, be done. Not have to replace curb, not have to repave the street. So, you guys are going to have that 2D file I told you, and you're going to put your curves in there, right? Copy the polylines for your intersections and your cul-de-sacs into your grading drawing. Because you have the geometry drawn, there's no need to redraw it. And your clipboard will allow you to copy and move it back and forth, all right? So you can just take literally the 3 curves for any cul-de-sac. Or simply take the 2 curb returns And then you need one line there, all right? So you need to start with basically 2 arcs in a line or 3 arcs. They could be, 1 or 2 polylines. But you're going to start with these objects. And I'm going to look at the existing conditions. I wish I could zoom in on this a little bit more. Yeah. Why did they take away my license? Okay. So I've got the existing curb. I'll draw it a little bit bigger. And I've got my proposed curb coming in. And again, bad curves, all right. But your corridor, assume that's the curve, really. Again, my corridor is going to end here, right? Because it's closer inside. So you're going to need to do that intersection. And let's start off with only the bottom of curb at the minimum. This is all BC, bottom of curb. Because I can always get the top of curb later. All right, so all right, and this would be assumed to be one curve and one line. This is the existing flow line, aka BC, or bottom of curb, or flow line. Depends on whatever your engineer calls it. But it's where the water would basically travel down that curb, right? This is my favorite design tool because I know how all the drainage is going to work if I design off of that. There are a number of people who design from top of curb. Can be done, no different, but I like to stick with the flow line. So you can draw a polyline from there to there, all right? And you can get every elevation on that line, right? Right? It's a 2D polyline when you draw it, but when we start getting into design, I need a 3D, and I know all those elevations, don't I? Everywhere along that line, they're on the existing surface. I have that surface, I make that a feature line, and I can get the elevations from that surface directly on to that, onto there. So this design process that I'm talking about is really much like that, where you're starting with your 2D, your polylines, lines, curves, whatever you have, and then all you're doing is assigning elevation. And in this, I know all the elevations I need. Again, if this is the flow line, I can turn that surface on and turn the triangles on, and I can literally trace a 3D polyline on top of it. Or, when I have a surface, you can use that surface to assign the elevations all along that. Google, Civil 3D, feature line elevations from surface. All right, that'll be a huge tool you're going to use a lot. All right. Similarly, I want you to draw a polyline across the entire end width of the corridor. So that is corridor width. Actually, I'll say full corridor width. Because it's going to go past the curb, right? My corridor is going to come past the curb to where? The corridor we designed.
The daylights.
Okay, yes, it ultimately ends at the daylight, but what's going to hit intermediately? Before the daylight. The right of way, right? This is the curb. Round of. This is the right of way. And then it daylights. Okay? So this here is the daylight point. So, you have one polyline that you drew, you made it a feature line, and you assigned elevations up here from the existing ground surface, right? Because we're tying in there. That's where our pavement is going to end. Then I told you to draw a polyline across here. What do I also know about that polyline? Isn't it the very end of the rough design I have right now? If I draw it right on top of the end of that corridor, do I know every elevation across it? Right, I already have that corridor up on my profile, computing my cross slopes, my top of curb elevations, my right-of-way elevations, and my daylight elevations. I know every elevation that even my crown, right? So you got bottom of curb, you got TC, you got BC, you got crown, you got the right-of-way and the daylight. Those are all the important elevations, right? That's my cross-section. Wasn't that the cross-section I made? The assembly I made? With my curb, my right-of-way at 2%, and then my daylight, right? Remember that sketch from last week? Right, and this was 6 inches, 6 inches. And when I attach this assembly on that corridor, where does it get this elevation from?
The existing circle.
Do I want that to be? Did we make proposed profiles? Right, remember we had the profiles that we made? We had an existing one, and then we drew our proposed grade over it. Remember that? All right, so this is the finished ground elevation from proposed profile. Right, and then the corridor is computing the elevation here at 2% for your width. It's computing your elevation here. Rising up ahead is computing your elevation here, here, and here or there. All right, that's how it's working. So, this is polyline number 1. Polyline number 2. Convert that to a feature line, elevations from your corridor surface. And again, I told you, you convert this polyline to a feature line and elevations from the existing ground surface. Right? This intersection is literally tying the proposed to the existing. So if I know this elevation, and I know this elevation, there could be 100 points between here, and I can just compute the average slope, can't I? Right? If I know this elevation from EG, and I know this elevation from my corridor BC, can I compute the elevation here at a constant slope? Right? Does that make sense to tie that in that way? Straight grade it down. There's a command that you can search, feature line. What do I call it? I can't even see it. Set grade / slope between points. I'll let you get that one. The command is set grade / slope between points. Okay. Something, did you guys do any feature lines in your 260 course? Okay. Feature lines have to reside on a site, or they're best to rely or to reside on a site. So when you create a feature line, you're going to be prompted to create or use a site. You can make one, call it your own name, intersections or whatever, or you can use the one that's there. If you keep all of your objects on one site, the same site, when you assign elevations to this, the endpoint of this will follow. When you assign elevations to this, the endpoint will follow. So, if I make this a feature line, this a feature line, this a feature line, and this a feature line. And again, where did I get these? Where did I get these two polylines from? That 2D design file I just told you to make with your buildings, driveways and curves, right? Copy, paste it in, convert it to a feature line. This we drew, making sure we hit the existing curve, bottom. This we drew at the end of our corridor. Draw in a crown line. Make sure there is a PI. What's a PI? Point of intersection. All right, there's a command to insert a PI on feature lines. Make sure there's a PI on there, on this. But you have 1, 2, 3, 4, 5 polylines right now. And you can actually draw 6 and 7. Approximate daylight. Which is also our LOD. What's LOD? Or LOG, depending on the engineer you're working with. limit of disturbance, limit of grading, limit of disturbance, where we're telling the bulldozers to stop. All right. Taking a lot. I'm going to try to boil this down to a few steps. Step number 1. Polyline. Top of curb, bottom of curb. Crown. Existing gutter or existing BC. Proposed end of corridor. You get 1, 2, 3, 4, 5, 6, 7, 8, 9 polylines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 polylines. Step number 2. Insert PIs at every crossing, right? We have one polyline here, but I've got TC crossing, BC crossing, crown crossing, TC, BC, and daylight. Your feature line insert PI command will work on polylines to make it very easy to do that. You just click on your corridor and put the PIs where you need them. Step number 3, convert the polylines to feature lines, keeping them all on the same site. Step number 4, elevations from surface. Existing BC from your existing ground surface. Proposed corridor tie from your corridor surface. Step 5. Step 5. Average any required grades along the BC and or TC, all right? Now, I want you to think about this. I told you that if all these feature lines are on the same site, and I assign elevations to this, the endpoint of this is going to pop up from 0 to 300 something, right where we are. If I assign elevations to this, to the corridor, these elevations are going to call up to 300 something, and this endpoint is going to follow up. Did it change this vertex, this elevation? Right, if you have a curve and a line, did it change that vertex there? No, it didn't. So this will still be at elevation 0. Right? You may have elevation 301, elevation 0, and elevation 300.
This might be a stupid question, but, so what are these steps for?
You're going to make a surface for this intersection,
Okay.
so you can get contours through it.
Okay.
All right? And it's also getting you used to the feature line tools that you're gonna use for your residential grading. All right, so this is a good introduction to 2 of your tasks. All right? So again, we start with those polylines, we convert them to feature lines, we assign elevations, and then we just need to average any grades where we don't know. And again, if this was a curve and a line, and you assign elevation here to the feature line, because this was originally at 0, where polylines are. This comes up to grade, this comes up to grade, this one is stuck down. In 3D, I'll be looking at a V. Right? Because it's up 300, elevation 0, and elevation 300 something. What we need to do is straight grade it. Right? You need to get that 0 out of there and get this elevation somewhere between that 300 and that 301. That command I told you, set grade slope between points, does that. It'll take this elevation, divide it by that length, and compute the elevation you need there to get that constant slope. And that's what it's doing. It's putting a constant slope from one elevation to another one when you do not know the intermediate point. Your bottom of curve you defined. There's another command you're going to use called stepped offset. And what it does is it allows you to take a 3D object, offset it both horizontally and vertically. And that's easy because if I know the elevations on my bottom of curve, I automatically know the elevations on my top of curve. I just got to add a ½ a foot, right? So you can use that command to generate a top of curve line, telling it to offset a ½ a foot over and a ½ a foot up. So that was step 6. Generate top of curve. Last step, number 7, put these feature lines into a surface as break lines. You can select them all, right click, and it says add to surface as break line. Or you can make your surface, call it INT1, expand that definition, and bring those break lines in. What you Google for this is create surface from feature lines, or add break lines to surface. So again, I want you to think about this generally as you have 2D line work that defines that intersection, and you just assign elevations from things you already know, your proposed conditions, your existing condition. And if you have intermediate, how would I know if I built this surface, I generated contours, how would I know if this was at 300, this was at 301, and that was at 0? I'd have literally 150 contour lines being generated, right? It'd be a big donut. And if you go to 3D view, I invite you all to use your 3D views when grading. This is something my co-boomers can't really get a grasp of. They are so used to designing with contours, reading contours, that it makes more sense to them than a 3D view. And that puzzles me, because if I have a 300-foot contour tool, I might not see that thing going down to 0, right? I might not see everything. Contours, in my opinion, are the biggest lie and the most inaccurate information on any civil engineering or surveying plan. The only thing that is accurate is the point they occupied with that, and you guys had your surveying class, right? The point they occupied and put that rod on and shot that is the only thing that's accurate. Everything in between that and the next point is interpolated, is it not? All right, so think about that. Your contours are lies, but they give you a good idea what's going on. In plan view, yes, I would know there's a problem here. I would see 150 contours using those elevations I gave you. If I went into a 3D view though, what I might see is that whole intersection basically up in 3D view, except for this guy that might shoot all the way down, right? And again, that's where we brought this polyline up from elevation 0 up to the existing surface. We brought this from elevation up to our corridor. It had the crown on it, and yeah, this guy should have been connected to crown. And then we got this elevation free from that one, this elevation free from that one, but it didn't know what this one was, and it left it at 0. And your 3D view, you instantly see that, and you can just then use that tool I gave you, which would interpolate that Z value at that curve and smooth that. All right, now, this would be a lot easier if I had my computer. But am I providing a decent description of what you're doing? I know it's tough, but you guys kind of get the idea? Yes or no? It's still a little fuzzy. Yeah, okay, all right. I apologize. Anyone have a laptop they can lend me with Civil 3D? Bring it on up. It would probably help you if you saw this, right? Yes? Okay. All right. Let me get a couple of my files. And we will run through this because we want to get through at least a cul-de-sac.
Yeah, the only intersection that we have is the proposed area with the,
That's like exactly what when we turn into our street. And then I guess we also have to do something for the cul-de-sac that he's about to go over.
So yeah, why don't you guys take 5 while I get this set.